In this video, we will go through the first two methods of factoring, then in later videos, we'll put them together to solve more complicated factoring problems. Let's start with finding the greatest common factor. The greatest common factor is abbreviated GCF. The GCF, the greatest common factor of a set of quantities, is the greatest or largest quantity that is a factor of all the quantities. That's why it's the greatest common factor. It's the biggest thing you can find that's a factor of all the quantities, that all of them have in common. Here it says the first rule of factoring, this is the first thing you should do when factoring, is to factor out the greatest common factor. So let's try it. Let's factor out the greatest common factor from some polynomials. In this first one, the polynomial we are factoring is 2x plus 6. We ask ourselves, of these two terms, what factors do they have in common? Well, they both have a factor of 2. The 2 is in common, but they don't share any other factors. 2x also has an x in it, and 6 also has a 3 in it. But the greatest common factor is 2. So we will factor out a 2 from both terms. When we do that, we take out the 2, and then imagine what's left when I take a 2 out of each term. When I take a 2 out of 2x, what's left is x. And when I factor 2 out of 6, what's left is 3. 2x plus 6 equals 2 times the quantity x plus 3. To check your work, you can always imagine what would happen if you multiplied out 2 times the quantity x plus 3. You would distribute the 2, and you'd get 2x plus 6. So we know that 2x plus 6 really does equal 2 times the quantity x plus 3. Let's look at number 2. We're looking for the greatest common factor of 8x squared and 12x. Well, 8x squared and 12x both have an x in them. So the greatest common factor is definitely going to have an x. The question is, what's the largest number they have in common? They both have 2 as a factor, because both 8 and 12 are even, but 2 is not going to be part of the greatest common factor, because there's something larger they have in common. They both have a 4 in common. 2x is a common factor, but 4x is the greatest common factor. So let's factor out 4x from the two terms. When I take 4x out of 8x squared, well, there's x left over. And when I take the 4 out of 8, there's a 2 left over. Notice that 8x squared is 4x times 2x. What's left when I take 4x out of 12x? What's left is just 3. 8x squared minus 12x equals 4x times the quantity 2x minus 3. Again, to check your answer, we can see that 8x squared is 4x times 2x. And 12x is 4x times 3. The minus in the middle, we didn't interact with at all. I'm just looking for the greatest common factor of both terms. The minus that's here in the middle is still here in the final answer. Let's look at one with 3 terms. In this one, we're looking for the greatest common factor of all 3 of these terms. Just like in number 2, we'll look at the y's separately from the numbers. The first term has y cubed, the second term has y to the 4th, and the third term has just y. The biggest power of y that they all have in common is just the y. So the greatest common factor will have a y. Now let's look at the numbers. What's the greatest common factor of 12, 20, and 28? Well, again, 12, 20, and 28 are all even. So 2 is a common factor. But 12, 20, and 28 also have 4 in common. They're all multiples of 4. So the greatest common factor will have a 4, not just a 2. I don't think anything larger fits inside of all of these, because 12 is 4 times 3, 20 is 4 times 5, and 28 is 4 times 7. The biggest thing they all have in common is they all have a 4, so the greatest common factor is 4y. Now I will factor 4y out of all three terms. These minuses and pluses between the terms, I'm just going to keep them. What you'll notice as you go through this class is when you are simplifying an expression by either factoring the expression or multiplying out an expression, the parts of the expression that you do not interact with, you just copy them down in each line, and then you don't have to remember them. So we keep the minus and the plus. Now let's factor 4y out of all three terms. When I take 4 out of 12, there's a 3 left. And when I take just one of the y's out of y cubed, there's 2 y's left. So I will have 3y squared. When I take 4 out of 20, there's a 5 left. And when I take a single y out of y to the 4th, I have y cubed. Finally, when I take 4 out of 28, I have a 7 left. And when I take y out of y, well, I took out the whole y, so it's done. This is it. 12y cubed minus 20y to the 4th plus 28y equals 4y times this quantity, 3y squared minus 5y cubed plus 7. To check our work, we could pick one of the terms, say 20y to the 4th, and make sure that 4y times 5y cubed equals 20y to the 4th. It does. 4 times 5 is 20, and y times y cubed is y to the 4th. Let's look at number 4. What do these have in common? Well, there's no coefficients at all. These have a coefficient of 1 that's sitting there, so we don't have to look at that at all. Instead, we'll just say, what do x squared and x have in common? The greatest common factor of x squared and x is just x. Both of them have an x, both terms have an x, but they don't have anything else in common. So let's factor out an x. When I take x out of x squared, I'm just left with one more x. This plus I'm going to keep. And then I ask, what happens when I take x out of x? You might think, nothing. But what do I mean by take x out of x? Like, remember in the previous problem, when I took 4 out of 28, I was left with 7. So when I say take out, what do I really mean? I really mean divide. The reason taking 4 out of 28 is 7 is because 28 divided by 4 is 7. So here when you take x out of x, what's left? It's not exactly nothing, it's 1. So if you ever notice yourself factoring something out of itself, what's left is just a 1. Let's check our answer. X times x is x squared, and x times 1 is x. So we got it. X squared plus x equals x times the quantity x plus 1. How about the second one? Gross. It has some x's and some y's. That's fine. Let's look at the x's and look at the y's separately when we're finding the greatest common factor. Just like always, I look at the two terms, or in number 3, I looked at 3 terms. I look at the terms and see what the terms have in common. Like, do they both have at least one x? Yes. Do they both have x squared? No, so x squared will not be a common factor. Okay, do they both have a y? Yes. Do they both have y squared? No. So the greatest common factor is just xy. Let's factor out xy. When I take xy out of the first term, well, I took all the x's, and I took one of the y's, but there's still a single y left. This minus just stays until the next step. Then I'm going to take xy out of the second term. When I take xy out of the second term, all that's left is a single x. Okay, here's number 6. Number 6 looks intimidating, but don't worry too much about it. We'll still find the GCF, the greatest common factor, by looking at the 3 terms and seeing what the 3 terms have in common. While we're looking at the 3 terms, we will do the numbers separately from the x's, separately from the y's. So this problem looks intimidating at first, but when we break it down into smaller and smaller pieces, the individual pieces are not nearly so difficult. Like, let's start with just the numbers. What is the greatest common factor of 12, 14, and 16? Well, they're all even, so the greatest common factor has at least a 2 in it. Are they all divisible by 4? No, 14 is not divisible by 4. Do they all have a 7? No. Do they all have a 3? No. The only thing they all have in common, all these 3 numbers, is a 2. So the greatest common factor is a 2. Now let's look at the x's. The first term has x squared. The second term just has a single x. And the third term has x cubed. What's the greatest thing they have in common? Well, they all just have an x in common. Finally, we look at the y's. The first term has y cubed. The second term has y to the 4th. And the third term has y to the 5th. What's the largest power that they all share? Well, they all have at least y cubed. So the greatest common factor has y cubed in it. So factor out this greatest common factor and see what's left. Let's leave a little more room than that. See what's left when I take 2xy cubed out of each term. I'll do the first term, and then there will be a plus. And then I'll do the second term, and then there will be a minus. And then we'll do the third term. So I take 2 out of 12, and I get 6. I take one of the x's out of x squared, and I get x. I take y cubed out of y cubed, and they're all gone. So this term is done. Then I take 2xy cubed out of the second term. I take 2 out of 14, and I get 7. I take x out of x, and it's gone. I take y cubed out of y to the 4th, and that's y. Finally, we do the third term. I take 2 out of 16 to get 8. I take x out of x cubed to get x squared. And I take y cubed out of y to the 5th to get y squared. I ran out of space here. Let's fix it a little. I took y cubed out of y to the 5th to get y squared. That one's a little tricky. What you might do is do that one off to the side, like how I did x divided by x equals 1 before. To take y cubed out of y to the 5th, I could imagine y to the 5th, like here's y to the 5th, and here's y cubed. Y to the 5th divided by y cubed is y squared. So that's why when I took y cubed out of y to the 5th, I got y squared. If you know exponent rules, then maybe you don't need to think about it this way, but yeah. Lots of ways to think about each problem. Let's look at 7 and 8. In number 7, I have 2 terms. I again look for the greatest common factor. Both terms have a in them, and they don't share a squared. The first term has a squared, but the second term does not have a squared. So the biggest thing they all have in common is just an a. Then I look at these numbers. Well, the first term has a 12, and the second term has a 22, so they definitely have a 2 in common. The first term is divisible by 4, but the second one is not. The first one has a 3, but the second one doesn't. The second one has 11, and the first one doesn't. The only thing they have in common is a 2. Now, this minus is a little strange. If you have a minus like this, you could take the minus out and say that the greatest common factor is actually minus 2a. If you do that, you'll get a slightly different answer, and it's still correct. Later, in like the next video, it will be useful to take the minus sign out as part of the greatest common factor if it is in the first term. So let's practice it now. Technically, the greatest common factor being 2a or negative 2a are both correct. Let's use negative 2a. So I will factor out negative 2a. When I take negative 2a out of negative 12a squared, I get 6a. Now, how do I take negative 2a out of 22a? Well, the same way we've done anything complicated when it comes to factoring out. To factor negative 2a out of 22a, you divide them. A divided by a cancels. 22 divided by 2 is 11. And when I divide a positive by a negative, I get a negative. So 22a divided by negative 2a is negative 11. If you're ever not sure about one of these answers, remember that you can always check by multiplying. The opposite of factoring is distributing, so you can check by distributing and multiplying this out. Negative 2a times 6a is negative 12a squared. Negative 2a times negative 11 is positive 22a, which is what we had. Let's look at number 8, the last one in this section. What do they have in common? Well, they're both negative, so I definitely want a negative sign in my greatest common factor. And they're both made entirely of a's. So what's the greatest number of a's that they have in common? Well, the most I can get out of there is a squared. Let's do it. I'll factor out negative a squared. When I take negative a squared out of negative a to the fifth, there's 3 copies of a left. When I take negative a squared out of negative a squared, well, just like in number 4, if you take something out of itself, all that's left is 1. So that covers these first 8 problems. Let's look at the second method. The second method here is called factoring by grouping. Factoring by grouping is about taking usually 4 terms and grouping them into 2 sets of 2, taking out the greatest common factor from both pairs of 2. So we kind of do the greatest common factor method twice, and that's called factor by grouping. So in this example, you look at this plus as though this plus is the one that's dividing the world into 2 terms, just like in the problems above. If you can break this up into 2 terms in your head, then you can see that the first term and the second term have something in common. Their greatest common factor is that they both have this factor of b plus c. Then we treat this b plus c just like all the greatest common factors in the problems before. I write the greatest common factor, and then I leave some parentheses open. This plus sign gets copied down. And I imagine what happens when I take b plus c out of the first term. If I take b plus c out of the first term, I'm just left with a. What happens if I take b plus c out of the second term? I'm just left with d. This step will be the hardest part of factoring by grouping, because you have to, in your mind, chunk this expression into 2 pieces to decide that this is the first term and this is the second term. And then you can use the greatest common factor method. This is done. Let's look at number 10. Number 10, I'm again going to split this into 2 groups and say, what do they have in common? Well, the first one has a plus 3, and the second one has 3 plus a. Those look a little different. Is a plus 3 the same thing as 3 plus a? Yes. Those are equal. So that's a common factor. So I will say the greatest common factor is a plus 3. Now let's factor a plus 3 out of these two terms. I write the greatest common factor, open some parentheses, leave space for both terms. This minus, I'm going to keep it in the next step. And then I say, what happens when I take a plus 3 out of the first term? Well, I get y. And what happens when I take a plus 3 out of the second term? Well, a plus 3 looks a little different in the second term, but I can still take it out, and I get minus w. So this quantity in number 10 equals a plus 3 times y minus w. Let's do the entire grouping method. Examples 9 and 10 will be the last step of a grouping method. So let's do it. These will be problems with polynomials that have 4 terms. So, factor by grouping. First, group the terms into 2 groups of 2. Then find the GCF of each. So we'll do 2 little miniature greatest common factor problems first. Then we'll finish the whole process by doing what we did up here in numbers 9 and 10. Let's see it. So 10x and 10y, what do they have in common? They both have a 10. wx and wy, what do they have in common? Well, they both have a w. So let's factor out a 10 from just these first 2 terms. I get 10. Write the greatest common factor, leave space for the 2 terms. When I take 10 out of 10x, I have x. When I take 10 out of 10y, I have y. Cool. This plus, keep it. I didn't use it, so keep it in the next step. Next greatest common factor problem. I have a w. I'm taking w out of 2 terms. If I take w out of wx, I have x. If I take w out of wy, I have y. I'm half done. All that's left is to do a problem like number 9 and 10, where now we notice that my first group and my second group have a common factor. Their greatest common factor is x plus y. So let's take x plus y out of these 2 groups of terms. This plus is surviving all the way till the end. When I take x plus y out of 10x plus y, I have 10. And when I take x plus y out of wx plus y, I have w. That's it. We factored by grouping. Let's do number 12. Number 12, I can split into 2 groups and do 2 little miniature GCF problems, greatest common factor problems. What do these first 2 terms have in common? Well, they both have an x. The first one has a 2 and a y, but the second one doesn't have those. The second one has a 5, but the first one doesn't have those. So the greatest thing we can find that they all have in common is just x. How about the second one? These don't look like they have anything in common. One's even and one's odd. Oh, they both have a 3. 6 and 15 are both multiples of 3. So the greatest common factor of these 2 terms is 3. Let's do these miniature greatest common factors. So I'll take out an x. When I take x out of 2xy, I have 2y. I'm keeping this minus sign. And then when I take x out of 5x, I have 5. Anytime you run across an expression or a piece of the expression that you haven't done anything with, just keep it until the next step. So this plus, I'm just keeping it. Now these last 2 terms have a greatest common factor of 3. Write the greatest common factor, then make some parentheses. Take 3 out of each term. When I take 3 out of 6y, I get 2y. When I take 3 out of 15, I get 5. What do I put between them? Well, any piece of the expression I didn't use, I should keep it in the next step. Finally, because I'm doing factoring by grouping, I'm hoping that these 2 mega terms that I have together have something in common. And sure enough, they do. They both have a 2y minus 5. So let's take 2y minus 5 out of both of these big groups. Same deal as before, leave some open parentheses. When I take 2y minus 5 out of x2y minus 5, all that's left is x. When I take 2y minus 5 out of 3 2y minus 5, all that's left is 3. If you're ever stuck and you go, wait, oh no, what was supposed to go here? Well, it's something from the previous step that you didn't use, namely here it's this plus. This is it. This whole polynomial factors by grouping into 2y minus 5 times x plus 3. Let's look at the next page. For more factor by groupings, notice that factoring by grouping is basically only useful when there's 4 terms. 1, 2, 3, 4. And the 4 terms can be grouped so that we do 2 sets of greatest common factors. This first one, the greatest common factor, is 1. These terms have nothing in common. Wait, the second one, they also have nothing in common. If this happens, it means factoring by grouping is not going to be very useful. Maybe there's some way that we can rearrange these terms so that the pairs of the terms will have something in common. So let's do that. Like 2y and 6 are both even, and 3x and xy both have x in them at least. So let's use the fact that addition and subtraction can be rearranged so we can do it in some other order. Let's put this plus xy over here. So I will just say that I could add and subtract in some other order. Let's see if this helps. Now the first 2 terms have a greatest common factor of x. And these last 2 terms have a greatest common factor of -2. Take out the greatest common factor. When I take -2 out of -2y, I just have y. When I take -2 out of -6, I have 3. Well, we at least got some little greatest common factors out, but did factoring by grouping work? If factoring by grouping works, these 2 big groups should have something in common. Sure enough, they do. They both have 3 plus y. Here's 3 plus y, and here's 3 plus y. The things I've circled here are equal. So I can take them out. I kind of like writing it as y plus 3 better. These 2 terms both have a y plus 3 in common. So I write y plus 3, leave some space. What's left when I take y plus 3 out of the first term? I get just x. And what's left when I take y plus 3 out of the second term? It's -2. Notice that factoring by grouping worked, but it didn't work immediately. Factoring by grouping only works if the pairs that you look at actually have something in common. If they have nothing in common, you can try rearranging them so that maybe factoring by grouping can work. Let's try number 14. The first 2 have an x in common. The second 2 have a y in common. So I'll factor out x from the first pair, and I'll factor out y from the second pair. If you're missing an operation, that's because you didn't copy it down from the previous step. Try to copy down everything from previous steps that you don't use. Now we look at these 2 groups, and we say, well, do they have anything in common? And the answer is no. The first group has an x and an x plus 4, but the second group doesn't have any of that. It might be that factoring by grouping just doesn't work here. Let's try some other pairs just in case. So let's try just rearranging things a little bit. Let's put the xy over with the x squared. When I do this, the first two terms now have an x in common, and the second two terms have nothing in common. Well, this is still pretty useless. When I factor x out, I get x times x plus y, and then the second term has 1 times 4x plus 5y. I can factor a 1 out, but again, my two groups don't have anything in common. So what I would say here is I would say this does not factor. I basically tried factoring by grouping, and it didn't work out. Let's look at 15. 15 has 4 terms, so again, it might work. Grouping says, let's put the two pairs of terms together and see if we can do little greatest common factors. The first two terms both have multiples of 5, and they both have at least x squared in them. This one has even more x's, but the largest number of x's they have in common is x squared. The second term, well, there's not much in common here. They're both even, so they both have a 2. Let's just include this minus in the greatest common factor. It just helps sometimes, especially for the more complicated ones in later videos. So we take 5x squared out of the first set. Take negative 2 out of the second set. When I take negative 2 out of negative 6x, I get 3x. When I take negative 2 out of 4, that's a little weird, but remember, I can always do a division problem to find out what it is. When I take negative 2 out of 4, it's negative 2. If factoring by grouping works, then the two groups will have something in common. Sure enough, they do. They both have a greatest common factor. They both have a common factor of 3x minus 2. So let's take out 3x minus 2 and see what's left. I take out 3x minus 2 from the first group, and I get 5x squared. I take out 3x minus 2 from the second group, and I get negative 2. Last one for this video. Let's do this. The first greatest common factor from the first pair is x. For the second one, there's really nothing in common except that we have this minus sign. So we'll just say that the greatest common factor is negative 1. Let's see if anything good happens. Take x out of the first pair. Take minus 1 out of the second pair. When I take the minus out of negative 3x, I get 3x. And when I take the negative 1 out of minus 4y, I get plus 4y. Well, we lucked out. It worked perfectly. They both have a 3x plus 4y. So I will factor out 3x plus 4y. When I take 3x plus 4y out of the first term, I'm left with just x. And when I take 3x plus 4y out of the second term, I'm left with just minus 1. So what did we do here? What we did here was a whole bunch of just greatest common factor. The same thing we did at the very beginning on the first page, where we looked at two terms and found if they had anything in common. Then we wrote the thing they had in common and opened some parentheses and filled in the rest. It's the same thing we did in number 1 that we did here at the end in number 16. But in number 16, we did two little greatest common factors and then took another greatest common factor out of each group, and that's called factoring by grouping. Factoring by grouping doesn't always work when there's 4 terms, like in number 14. It just doesn't work. But factoring by grouping often works when there's 4 terms.